Hey, welcome back. This is 3.3 Properties of Logs, continuing with our exploration of the logarithm. Okay, there's three main rules. The first rule is called the product rule, and there are some restrictions on this rule. You can't just use it haphazardly. Let B, M, and N be positive real numbers. So any number greater than 0, and we don't let b equal 1. Okay? Supposing you have all that true, the log base b of m times n can be converted into an addition problem. Okay? I believe if you've ever seen a slide ruler, which is what they used before calculators, the main goal of the slide ruler was to convert multiplication into addition, because addition is a lot less computationally exhaustive than multiplication. I mean, think about it. Which would you rather do? This problem or this problem? Right. I would choose this problem. That problem's a lot easier. So you can imagine if you had to multiply some huge numbers and it turns out you can convert it into an addition problem, you would be in a good place. And that's kind of what I believe the slide rulers do, if you've ever seen one of those. So I think maybe my dad had one of those. So that would be way back in the day. Okay. Okay, so it changes multiplication into addition. It's magical. All right, so an example, they're going to want you to kind of expand these logarithms and simplify them. So here we have a common log, so log base 10 of 10,000 times x, and you can split this into an addition problem. So it's the log of 10,000 plus the log of x. And then we can simplify this guy right here. Okay, so we're asking ourselves 10 to what power equals 10,000? And all you have to do is count the number of zeros. And that's 1, 2, 3, 4. Right, so this will be 4 plus log x. Okay. Okay. So the next rule is like that, but it's a quotient rule. And what it does is it changes division into subtraction. Okay, quotient rule. And of course you can go in the other direction too. You can change subtraction of logs into the log of a quotient. So again, we have some restrictions. So let b, n be positive reals. So it's basically any number you can imagine besides the complex numbers, or rather besides the imaginary numbers, right? Real numbers are actually complex numbers with imaginary part 0, so I can't really say besides complex numbers. That wouldn't work. So anyways, b, m, n are positive real numbers, and then b, again, can't be 1. And if you have the quotient of m and n, you can change that into the difference of logs. So again, it's kind of changing a division problem into a subtraction problem. And again, that's usually computationally easier. So let's look at an example of that. So an example, log of x over 1,000. Okay, common log, so log base 10. And we can split that up into two logs, so log of x minus log of 1,000. And then the second guy here is just asking the question 10 to what power equals 1,000? And of course that's 10 cubed, right? So we have log of x minus 3. Okay, the last rule then is the power rule. Power rule. And again, we have some restrictions. Let b and m be positive reals. And then let b is not equal to 1. And then let p be in p is real. And so we have log base b of m to the p. Okay, how can I convert that? You can convert that into product. Okay, what you're going to do is take that power p and put it in front of the log, and that'll do the trick. Okay, that makes things a little easier somehow. So, for example, we have the ln of the 7th root of x. We can rewrite this as the ln of x to the 1/7. It's one of our exponent rules. And then we can take this 1/7 and plop them in front via the power rule. We'll get ln 1/7 ln of x. Okay. One little tidbit to the side here. If you have ln of x squared and you do this power rule, sometimes you'll see it rewritten as ln 2 ln. So if you take the 2 and put it in front, right? ln not of x, but of absolute value of x. Okay? And that's just so you can keep the domains consistent. Okay, the domain of ln of x squared are all real numbers such that x squared is greater than 0, right? And that will be everything on the number line except 0. So the domain of that thing is -infinity to 0, union with 0 to infinity. Okay, so to make this other equation on this other side sort of the same thing, in other words, have the same domain, they put in those absolute values. Okay? So this is just in case you take calculus and you keep taking a bunch of math classes, as seen in calculus. You're not going to probably see it here. Calculus. All right, so don't worry about that. You can blow that off unless you're going to keep taking math. Okay. So section 4, anyways, using all these rules to expand logarithms. And you want to get rid of all the fractions, the products, and the exponents inside of the log. Okay? Get rid of fractions, products, exponents from inside the log. Okay. And depending on what you need to do with the log, you're either going to be expanding it or you're going to be condensing it. And that these calculations, again, are very important later on in math. So anyways, 20, or an example, used to be 22, I don't know if it is anymore, log base b of xy cubed. Okay, so the first thing we do is note that there's a product here. Okay, there's a product, it's x times y cubed, so we'll use the addition rule to simplify that. So we get log base b of x plus log base b of y cubed. Okay. On the second log, there's an exponent. We want to get rid of that. So it's going to be log base b of x plus 3 log base b of y. Okay. Compare that thing to this example, log base b of xy cubed. Okay. In this example, you don't really have a product on the outside, right? You have xy to the third power. You can take the 3 because it's applied to both of these terms and put it in, use the power rule and put it on the outside, log base b of xy. And then you could use the product rule to split that up, but you would have to go 3 times log base b of x plus log base b of y. And then that would equal 3 log base b of x plus 3 log base b of y. Okay. So compare and contrast, right? They're not the same. In particular, the first term in our answer on the last guy doesn't have that 3 in front. Okay, and then this guy does have the 3. And it's because everything is inside the parentheses in here, raised to the third power. Okay. Let's look at another. So I got log base 8 of 64 all over the square root of x plus 1. Okay, so I have a quotient of two things, so I'm going to use the quotient rule. So log base 8 of 64 minus log base 8 of, I'm going to rewrite the square root as a power of 1/2, so x plus 1 to the 1/2. Okay. I can simplify the first one. That's really asking x to what power equals 64, and that's just 2. Right? So this will be 2. And then minus, on the second guy, there's an exponent I want to get rid of. So I'm going to take that and use a power rule, put it in front. So minus 1/2 log base 8 of x plus 1. Let's get another. So they get more and more complicated now. Log base b of x cubed y all over z squared. So overall, I see a quotient, right? So that's where I'm going to start. I'm going to do the quotient rule. I have log base b of x cubed y minus log base b of z squared. Okay. And then in the first log, there's a product, x cubed times y. So I'll split that up using the product rule. Log base b of x cubed plus log base b of y minus log base b of z squared. Then I see some exponents. I need to get rid of those. So I do power rules. So 3 log base b of x plus log base b of y minus 2 log base b of z. Okay. And then that would be as good as it gets. Okay, getting harder now. Log base b of the cube root of x times y to the 4th all over z to the 5th. Okay. So the first thing I see that I want to do is a quotient. So I'll have log base b of the cube root of x times y to the 4th minus log base b of z to the 5th. Okay. And that's my b, not a 6. It looks like a 6. It is. I tried to put a nice corner on the bottom of it. It doesn't always work. My 6s look more like that. Okay, so that's a b, as in beta. Okay, so now on the first term I see a product, so I'll go log base b, and I'm going to rewrite x, cube root of x as x to the 1/3, because I'm going to do a power rule on that, plus log base b of y to the 4th minus log base b of z to the 5th. Okay, and then finally just do a bunch of power rules and you'll be done. So 1/3 log base b of x plus 4 log base b of y minus 5 log base b of z. And that's it. Okay. One more of these. So now I have the natural log of x to the 4th times the square root of x squared plus 3 all over x plus 3 to the 5th. Okay, so there's a big quotient there, so I'll use a quotient rule. ln of x to the 4th times the square root of x squared plus 3 minus the ln of x plus 3 to the 5th. Then this first term has a product, so I'll rewrite that. Ln of x to the 4th plus ln of the square root. So let's rewrite the square root as a 1/2 power. And then minus ln of x plus 3 to the 5th. And then you're doing a power roll, right? 4 ln x plus 1/2 ln of x squared plus 3 minus 5 ln of x plus 3. Okay. In the back of my mind, I'm kind of thinking, all right, there's kind of an order here, isn't there? It's like we do quotient rule, if there is one to do, and then we do product rule, and then we do the power rule. Okay. Let's say, for example, we're going to go in the other direction. In other words, condensing the log. So we're going to start like at the end where we have a bunch of logs being added or subtracted, and we want to end up with one log. Condensed logs. It seems like we'll probably be going in the other order, right? You use the power rule to bring in any coefficients, then do a product rule to combine, and then maybe a quotient rule. Okay, that's what I'm thinking. So anyways, Condensing log, what do we want to do? We want to rewrite everything as one single log expression with no coefficient. Okay, so let's look at some of these now. So here I have the ln of x plus the ln of 3. Okay, so it's a plus, that means product rule. So I can rewrite this as a product, x times 3, or rather 3 times x. Okay. And I just put parentheses there to remind the reader that it's ln of 3x, not ln of 3 times x. Okay, so it's an important distinction. Let's look at some more. Log of 3x plus 7 minus log of x. Right? So this is a quotient rule. Log of 3x plus 7 all over x. You just take the insides of this and put it over the insides of that guy. More. So 5 log base b of x plus 6 log base b of y. Okay. So now I have to kind of go in reverse, right? So if you look at above, kind of the first step I would do in reverse is the power rule. And then after that, I'm doing product rule, and then I'm doing quotient rule. Okay. Okay, so power rule first. Log base b of x to the 5th plus log base b of y to the 6th, and then I do a product rule. So this will be log base b of x to the 5th times y to the 6th. I'm going to put some parentheses so my reader knows all of that is inside the log. Okay. Let's try another. So I have 1/3 times log base 4 of x minus log base 4 of y. Okay. Actually, there's 2 orders you could do this. You could distribute the 1/3 and then do a power rule, but you could also just combine the parentheses first. So you could go log base 4 of x over y, and then do a power rule. Okay, this is the same as 1/3 log base 4 of x over y, and do the power rule. Okay, I don't know why I just did that, but there we go. Okay, so log base 4 of x over y to the 1/3, and then we could rewrite that as a cube root. Log base 4 of the cube root of x over y. Okay. Okay, so there's more than one way sometimes to skin the cat. Okay, let's move on to another example. So here we have 1/3 log base 4 of x minus log base 4 of y plus 2 log base 4 of x plus 1. Okay. Okay, I'm going to do the parentheses first like I did in the previous problem. So I have 1/3 times log base 4 of x over y, and then plus 2 log base y, base 4, my 4s look like y's apparently, of x plus 1. Then I'm going to do a power rule. So I get log base 4 of x over y to the 1/3 plus log base 4 of x plus 1 to the 2. So I just take the 1/3, bring it in, take the 2, bring it in. Okay. And then I have kind of a product rule. It may not be clear exactly how to put those two together. So let me do this first, and maybe it'll help. So log base 4 of x to the 1/3 over y to the 1/3. So x over y to the 1/3. Let's play around with that in the margin. This is equal to x to the 1/3 over y to the 1/3. And then x to the 1/3, you can rewrite that as cube root of x over the cube root of y. Okay? So I'm going to rewrite that. Cube root of x over the cube root of y plus log base 4 of x plus 1 squared. And then I can multiply these two out, and it might be a little more clear as to how I'll put everything together. So I'll have log base 4 of the cube root of x over the cube root of y times the x plus 1 squared. Right? And x plus 1 squared is the same as x plus 1 squared over 1. So to kind of write it so it doesn't look like a huge mess, I put that x plus 1 squared into the numerator. It's just a fact of multiplication. Right? So cube root of x times x plus 1 squared is cube root of x times x plus 1 squared. And then cube root of y times 1 is just cube root of y. Okay? And that would be kind of your official state-sanctioned answer that we would want on a written test. Okay, okay, you not necessarily have to show the work. In general, what I would do is kind of skip all of this stuff. So I would skip all of that, unless I had to do it, and then I would write it out. But for you guys, I wrote that out, but in my brain, I kind of think just going from here to here. Okay. Okay, but if you got to write it out, I guess you got to write it out. This is the way it is. Anyways, change in base formulas. So this is helpful if you're used to working in one kind of base, but the person is giving you a different base. So in particular, you can change a base, b, into in terms of another base by doing this transformation. So you'll just take log of whatever other base you want of m, and then put that all over log of whatever base you want b. Okay, so it's, the m is right there, and then the base is going right here. Okay, so I usually convert everything to natural logs. So if I see something like log base 4 of 5, I'll automatically convert it into the ln of 5 all over the ln of 4. Okay. So for example, let's say I wanted to evaluate log base 16 of 57.2. For us, this is a real problem, right? Because on your calculator, you probably don't have log base 16. You probably have the common log. You probably have the natural log. You may not even have the common log at this point. So how do I do this on my calculator? Well, you're going to go ln of 57.2 divided by the ln of 16, and that will give you the answer. Okay, and it's approximately 1.4595-ish. Okay. Okay, so that will do us for 3.3. A lot of good stuff in here. If you keep taking math, you're going to have to kind of know this stuff very well. Thanks for watching as usual, and I will see you next time.